Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. All right, now students, what we're going to talk about is applying exponent rules. And we're towards the end of the video series, but we're going to focus on negative exponents and zero exponents. The video after this will be a self-quiz. All right, let's look at some problem sets. There are two rules we're going to apply to the problem sets that you'll see in a moment. And the first one is about negative exponents. Negative exponents move the term into the opposite position, top or bottom. The other one is anything raised to the zero power equals 1. Now let me show you some examples of how this works and what this means. So for the first rule, negative exponents, here is an example. Let's say we have x to the negative 2 power. Well, that means that we would put x to the second power, but it would be in the denominator. All right? So it becomes 1 over x squared. That's a positive 2 exponent now. Now let's say we have x to the third, y to the negative fourth. Well, x to the third is still going to be x to the third, no change there. But the y to the negative 4 power drops down into the denominator of a fraction. So it becomes y to the fourth in the denominator, x to the third over y to the fourth. Okay, that's kind of a combination of things happening there. On this one, I have x squared on the top of a fraction and y to the negative 3 on the bottom of a fraction. Notice it says that a negative exponent drops or moves things to the opposite position, top or bottom. If it's already in the bottom, then it actually moves to the top. So it's maybe a little confusing, but you just need to see some examples to see how this works. It's going to be x squared y to the positive 3 power. All right, we're going to put this together in an example in a moment. But that all has to do with negative exponents. Okay, anything raised to the 0 power equals 1. Well, 3 to the 0 power, that equals 1. 9.2 to the 0 power, that equals 1. And 1 to the 0 power equals 1. How about x to the 0 power? Yep, that equals 1. So anything raised to the 0 power is 1. And here's why. Okay, we have k to the third power divided by k to the second power. Well, from a previous video, you know that we can do k to the 3 minus 2 power, which is k to the first. Alright, so let's use the subtraction rule and see what happens. What if we had k to the third power divided by k to the third power? Alright, well, we could say that that's really k to the 3 minus 3 power, which is k to the 0 power. Well, we know if we have k to the third power divided by itself, those would cancel out, and the expression really is worth 1. Well, we know then that k to the 0 power must be the same as 1. So anytime we get the exponents subtract each other out, in other words get 0, then the value is 1. Now it's a hard rule to remember, but it's easy to work with once you understand. Now I want you to use these two exponent rules, the negative exponent and the 0 exponent rule, to simplify these expressions. Go ahead and hit pause on the video and try this on a piece of paper first. Alright, here you see the correct answers, and I hope you gave these a try. Let's look at number 23. Before I start putting this together and actually multiplying it, notice that this x to the 0, it's not 4 to the 0 power, it's only x to the 0 power. So that is going to be 1. Okay, and we can kind of ignore that for now. And y to the negative 2 is actually going to drop it down to the bottom of the fraction. Alright, so here's what we've got. We've got 2x squared y squared times 4 times 1, which will still be 4, And we also have this y to the fourth right here. And all over, that's where that y squared drops down. So y squared is in the denominator. Okay? Now notice that this y squared can cancel with that y squared. And when I put it all together, 2 times 4 is 8. X squared times y to the fourth is just squished together, and that's my final answer. Alright, so we just have to move a few things around. Now in number 24, u to the first is going to drop down to the denominator. V to the third is going to drop down to the denominator. And we put it all together, we're going to get 8 over v to the third. Because when we write it as a fraction, you notice that this u cancels out with that u, and I would get 8 on the top and v to the third on the bottom. Number 25. Nothing to move around here, no zero or negative exponents, so we just multiply it together. 2 times 3 is 6. Y to the first times y to the third is y to the fourth, and x to the fourth stays the same. Now you could flip the, or move the x's and the y's around alphabetically, which would actually be better form. Number 26, this u squared, because it's a negative 2 there, is going to drop down, and that's going to put it in the denominator. So let's go ahead and do that first. And then on the top we have 2 times 4 is 8. We have the v to the third is still going to be on the top. And I have u to the fourth here. Now of course when we do some canceling here, that's actually going to give me a u squared on the top. And that's what it looks like all put together. Alright, let's look at 2 more examples. Go ahead and give these a try. Alright, as you can see, number 27 is 8y squared x, or 8xy squared, if we put it in proper order. So, how do we get that? Well, this 2 is still going to be a 2 on the top. X to the negative 1 becomes x to the first on the bottom, and I don't need the 1 there anymore. Y to the third stays on top because it's already a positive exponent. And the 4 is being multiplied here on the top. It does not move. X squared stays on the top. And y to the first does go down to the bottom. So that's just plain y. Now when we do our canceling, notice what happens here. You're going to get y canceled on the bottom, and that makes it actually y squared. Okay? And this x cancels out one of these x's, so I can pretty much just ignore that exponent there. Alright, so you put it all together and you would get 8y squared x, or 8xy squared. And number 28, well, this is 4x to the 0, which is going to be 1. You can ignore it pretty much. And y to the 0 is also another 1. Anything to the 0 power is 1. So it's 4 times 4 times 1 times 1, which is 16. And we have x cubed y squared. So final answer, fairly simple there in that case. There you go. Alright, now tune into the next video, how to apply exponent rules self-quiz. It'll be a good test to see how well you've done with all these exponent properties. Thanks a lot for watching this video. Alright, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live, online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. Alright, study hard,